Okay, I'm picking up with number 14. Number 14 is a multiplying problem. So you've got 5p minus 5 over p times 6p squared over 9p minus 9. You do want to make sure when you're multiplying, go ahead and factor before you multiply. If you're adding and subtracting, you want to add or subtract before you factor. So the top here, 5p minus 5 has a GCF, it's 5. That'd be 5 times p minus 1 over p. And 9p minus 9 is 9 times p minus 1. So then cancel any common factors you may have. Like the p minus 1s, that's the same. So I cancel that out. I have a p here and a p squared here. So I could take away a p and it'd leave me with just one p on the top. And then I have a 6 on the top and a 9 on the bottom, and those have a common factor of 3. 3 goes into 6 2 times, and 3 goes into 9 3 times. So I end up with 5 times 2 times p on the top. That's 10p on the top, and then 3 on the bottom. All right, number 15. Number 15 is another multiplying problem. It's k squared plus 4k plus 4. So you want to factor that. And k squared plus 11k plus 18, you want to factor that. So trinomial, two numbers that multiply give you 18, add up to 11. K squared plus 9k, that has a GCF. And then k squared minus 6k minus 16. All right. So on the top, I'm looking for two numbers that multiply give me 4 and add to 4, which is 2 and 2. I'm looking for two numbers that multiply give me 18 and add to 11, which would be 2 and 9. Here I have a GCF, it's k times k plus 9. And then here on the bottom, I'm looking for two numbers that multiply give me negative 16 and add to give me a negative 6. That'd be negative 8 and positive 2. And once you get it all factored, you look for common factors. So like there's a k plus 2 here and a k plus 2 here. Factors can be over each other. They can be not over each other, as long as one's in the numerator and one's in the denominator can be canceled. So here I have a k plus 2 and a k plus 2. I have a k plus 9 and a k plus 9. And that's it. My answer is k over k minus 8. You cannot cancel these. They are terms, not the k, and the k minus 8 is not a factor. It's a term. All right, number 16 is a division problem. So with division, z squared plus 5z plus 6 over z squared plus 7z plus 12. I'm going to need to factor all this, but I got to worry about the division first. So it's done a lot like that last problem, except for this is division. So what I'm going to do first is I'm going to rewrite the first one, and you may can skip some of these steps. So rewrite the first fraction or rational expression, change division to multiplication, and then flip over the second rational expression. So what was in the denominator becomes the numerator, what was in the numerator becomes the denominator, and then factor. All right, I'm looking for two numbers. I'm going to put a z and a z. I need two numbers that multiply give me 6 and add to 5. So 3 and 2. All right, here I'm looking for two numbers that multiply give me 12 and add to 7. So that'd be 3 and 4. Same thing here. This is exactly z squared plus 7. It's the same thing. All of that cancels out. And then on the bottom, z squared plus 2z, I have a GCF. It's z. And then z plus 2. All right, that's now completely factored. The z squared plus 5z plus 6 factors as z plus 3z plus 2. The z squared plus 7z plus 12 factors as z plus 3z plus 4, both places. And then finally, the z squared plus 2z has a GCF of z. Cancel out anything that's the same. So z plus 3, z plus 4, z plus 3, z plus 4. Cancel those out. And then cancel out a z plus 2. And my answer is z plus 3 on the top and z on the bottom. Number 17. 17 is another division problem, but it's already been factored. 17. It's 2x minus 7 times x plus 1 over x plus 6, x, and that's a 6 if you can't read it, x minus 4 divided by x plus 1, 3x plus 7 over x plus 6, x minus 4. Do not try to cancel before you flip it. So keep the first one the same, 2x minus 7, x plus 1 over x plus 6, x minus 4, and then change it to times, and then flip this second one over. X plus 6, x minus 4 on the top, and x plus 1, 3x plus 7 on the bottom. Now cancel any common factors you may have, like the x plus 6's can cancel, an x plus 1 will cancel, an x minus 4 will cancel, and I end up with 2x minus 7 over 3x plus 7, which is D for an answer. All right, then we start adding and subtracting. To add and subtract rational expressions, you have to have the same denominator. So 4 over 13x plus 8 over 13x, these do have the same denominator. So on the top, it's just going to be 4 plus 8, and they share the 13x as the denominator. So it's just 12 over 13x, and that's how you do number 18. Just add them together and keep the denominator, 12 over 13x. Again, number 19 is the same way. It's 11 over 5x squared minus 8 over 5x squared. So the denominator is going to be 5x squared, and the top is going to be 11 minus 8, which is 3 over 5x squared. All right, number 20. Number 20 is m squared minus 9m over m minus 3 plus 18 over m minus 3. All right, these have the same denominator, so on the bottom it's going to be m minus 3. On the top it's going to be m squared minus 9m plus 18 over m minus 3. And then that top can factor. It's a trinomial. I'm going to put m and m. I need two numbers that multiply to give me 18 and add together to give me a negative 9. And so that'd be a negative 6 and a negative 3. Because they multiply together give me positive 18, they add together give me negative 9, and then I can cancel the m minus 3's, and my answer is m minus 6, because that's